Okay, so we have already, I told you I was kind of giving you a sneak peek. We've already talked about the tangent line. Oh, got my jacket zipped up. Check out my t-shirt. I wore it specially for you guys today. Sometimes I go off on a tangent here. Y'all are jealous. You can order one on Amazon if you want. The graph of f is shown to the left along with the line tangent to f. So Mr. Passwater really is not introducing tangent lines until right here, but I felt led to go ahead and give it to you a little bit early. So we've kind of already looked at this, right? It says little lines that just touch at one little point on the graph. So in calculus, we will learn that the slope of the line tangent to the graph of f at any given point is the true rate of change. It's called the derivative, is what we look at here, but we're not in calculus yet. We're all going to take it next year because it's the most fun class, but we're not there yet. So right now we're just estimating, right? So,
Is there any specific way we're supposed to go on tangent lines, or is it just like whatever we think is right?
right now, what we think is right. There are, like, when you're in calculus, you can actually calculate it, get the exact answer. But for what we're doing here, it's a guess, right? So, particularly a couple of these I think are a little hard to draw in, but most of them aren't too bad. So while we cannot find the exact slope, we can sketch and guess, right? Get a good idea of what's happening here. And that would be like the rate of change of the function at that point, right? So for example 6, it says estimate the rate of change of f at x equals -4 using the slope of the line tangent to f at x equals -4. So we're talking about this line they've already drawn in for us. We are supposed to estimate the slope of that line. Now, Mr. Passwater is a little bit difficult here because those do not go perfectly through grid lines, do they? Like, even this one right here, this is close. That's almost grid lines, but not quite. I think that one's almost perfect. He didn't give us one that was like easy, right? But we're just estimating at this point. I would find the points I could find that are closest to hitting perfectly at grid lines. So here, I'd just go ahead and put that one on the grid line there. It's actually a little bit below, I think. And then you can either use those points to do slope formula, or you can just count it. So if you're just counting it, you're just doing rise, how far you go up. So you go up 1, 2, 3, 4. Over run to the right, 1, 2, 3. So my estimate right here would be 4/3. Now you might pick different points. You might, guess that this is maybe like, 2.3 and try that. You could be a little bit off. This is an estimate. It's fine. But this is pretty close. Somewhere around 4/3, which would be about 1.3 repeating, is our answer here. Something close to that. Okay, 7 wants us to sketch in the tangent lines. So some of these I think are really easy to sketch in. Some of them I think are difficult. Anytime you are at like a maximum or minimum point, I think those are the easy ones. You're just looking at like a little horizontal line right there. And so what we're trying to do is just like sketch a line that just touches that graph once. Here, that would look something like this. Here, that's not great. Something like this. Here, something like this. The one I think is kind of hard is this one, because it's almost a straight line at that point anyway, right? So, the tangent line is probably going to be almost the same as the line itself, right? So I think it's a little hard to draw. If you get a section where it's very close to looking like a straight line, the tangent line is going to almost look like it's the same as the graph. And if you have a section where you do have a straight line, like we have some sort of piecewise function, then it doesn't have a tangent line, but the slope of that section is the slope of that graph, right? So you're like, you can't draw a tangent line because it is a line, but your slope is constant there. Okay? And then 8 says, does the graph of f appear to have a greater rate of change at x equals 4 or x equals 5? What do you guys think? X equals 4 or x equals 5? 5. And how can you tell, Layla? It's steeper. And we're talking about positive slopes here, right? Now, be careful with steeper if you're talking about negatives, because the steepest slope negative would actually be lower, right? But the slope is steeper here, so we could say the graph of f has a greater rate of change at x equals 5 because the slope of the tangent line is steeper there. Now is a good time for me to warn you about a calculus cuss word that we are not going to say in this class. So this is pre-calculus, so I'm preparing you. You guys are not used to like answering math questions with sentences much, right? We don't really, I'm going to be honest, I don't love to do it really, but we've got to be able to do it for classes like these. And, you know, I haven't had many students like major in like straight math, but if you are considering like majoring in math, where you're going to take like very high level math classes, a lot of your classes are going to be like proof classes where you have to write like these big long like explanations of things and why they happen, and there's so much writing. And when I majored in math, I didn't realize that. I thought I was just going to do like harder and harder math problems. But like whenever I took like I had to take advanced calculus, it was like proving of calculus. I took abstract algebra. Abstract algebra, I didn't know what that was going to be. It sounded like it would be that hard. It was like proving algebra things that you already like knew how to do, but you had to prove why they always worked. Instead of my teacher told me so and it has to work out this way, you have to like write these big long proofs. Like anybody who is going to find themselves in those classes, which I realize is probably not too many of us, but maybe a few of you might be interested. Like this gives you some practice on that, like that proof writing. You have to be very specific. Anybody that's going into like any type of science field where you might have to write a report about something that you're doing, you have to be very specific in your wording because you cannot just say general, vague things that are not, you know, like you and I know what they mean, but when they're written down on paper and a stranger looks at them, people don't really know. So, some of you may be inclined to answer this question by saying, it is steeper at x, or it is steeper at x equals 3, or it is greater at x equals 5. It is my calculus cuss word. It is the word that we want to stay away from. You pretty much, when you're writing an explanation for anything on a question, you should never use the word it. If you find yourself using the word it, stop and ask yourself, what is it? And say that instead. Okay? So like here, I could have said, it has a greater rate of change. But I don't mean it. I mean the graph of f, right? Has a greater rate of change. Or I could say, it is steeper. Don't say it is steeper. The slope of the tangent line is steeper. Right? So, I've started this new in calculus. You can see I've already got a couple. One poor kid lost his on the first day. This is my swear jar. I'm going to give you guys 2 weeks before I start the swear jar for you, because we got to kind of get in. You guys haven't answered questions with sentences. We'll get through the first test before I start the swear jar for you. But in calculus, I have started a swear jar, and if they say it, not just it in general, because it is hard to, like, it is a hard word to take out of your vocabulary. But if they say it, whenever they really meant f of x, or they say it when they meant, in their case, the derivative of f of x, but you guys would be talking about the rate of change of f of x. I am taking their late worker bathroom passes and putting them in the swear jar. So we'll start this up soon. Just be looking forward to it there. And we'll try to keep too many things out of there. They've told me, well, they don't mind giving up the bathroom passes too much, but they told me they would rather give me actual money than the late work passes. But I think that'll get me in pretty big trouble if I start collecting actual money from my children for saying the word it. So we won't do that. But it does make you like more mindful about like how you're expressing yourself. I'm not good at this either. I am not very formal in the way that I speak a lot of times, but it is very important in a lot of fields that you're like really specific. So, all right, let's keep going. Here is that same chart that we've had several times, right? I've put it here again to remind us, right? If the graph of f is increasing, the rate of change of f is positive. If the graph of f is decreasing, the rate of change is negative. If the graph of f is concave up, the rate of change is increasing. If the graph of f is concave down, the rate of change is decreasing. It will do you well to memorize this. I find myself writing it down on problems a lot of times just to organize my thoughts about what's being asked here. So in example 9, we've got this graph. It says the graph of f is shown above. Says above because I didn't change it whenever I moved this over. These notes were like 6 pages long. I got it down to 4, which is still pretty long. But complete the blanks below to correctly describe the graph of f and the rate of change of f. So, oh no, where I moved it, it moved these things. I've messed it up. I need to go back and fix that. The graph of f is blank and concave blank. Okay, that up down's definitely supposed to go here. Okay, so let's. I'm pretty sure this one was supposed to have increasing or decreasing underneath it, right here. So the graph of f is, are we increasing or decreasing on this graph? Left, right, increasing, right? So it's increasing. And how about concave up or concave down? For that one. Concave down. So concave down. So our graph of f is increasing because from left to right our graph is going up, and our graph is concave down because it's sort of curved down looking, right? Now we've got to justify that with rates of change because the rate of change of f is blank and the rate of change of f is blank. So in this first blank they're looking for increasing, decreasing. No, I think in that first blank they're looking, see this is confusing because I've messed it up where I didn't fix this where I moved things around. That increasing and decreasing is supposed to be down here. This blank right here is supposed to be positive or negative. There. Okay. You definitely, we could just go like straight to the table right here and say, oh, well, f is increasing and concave down. and then think about what that tells us about the rate of change of f. Positive, decreasing. That's one way to approach it. If you know that table, that works great. You can also think about your tangent lines. So if you think about your tangent lines here, because the little slopes for your tangent lines, those give you the rate of change at every point, right? And out here on the end, this starts to get very linear looking. So like my tangent line, like if you drew this way on out, it would not be the exact same line, but it looks pretty much like the same line, right? So first of all, are the slopes of these little pieces of tangent line, are they positive or negative slopes? They're all going up, right? So they are all positive. So we're looking at positive slopes. And then again, I've just been guessing. So like I'm gonna say this has a slope of 3. So if that has a slope, that first line has a slope of 3. Then Shayla, what do you think the next one might be? Like if this slope right here had a slope of 3, what would you think like maybe would be a guess for the slope of the next one? 2? Be a good guess? All right. Then Ava, what do you think for the next little tangent line there? Maybe 1. So Zane, what do you think about that last one? A half? That'd be good guesses. Now I'm just guessing to like, you know, get some numbers on the page because I like numbers and that helps me organize my thoughts, right? Especially if I've forgotten which order this table goes in, right? So 3, 2, 1, 1/2 are my rates of change increasing or decreasing? They're decreasing. So when we're talking about f, that's the easier part of it. You're just looking at the function and seeing what it looks like. If you're talking about the rate of change of f, you're thinking about those little pieces of tangent line that you would have there, right? So the next page has 3 examples. I want you guys to try those on your own. The first part, it asks you about the graph of f being positive or negative and increasing or decreasing, and then it asks about the rate of change being positive or negative or increasing or decreasing. And so when we're talking about the graph of f being positive or negative, that is going to be above the x-axis or below the x-axis. We looked at that just a teensy bit maybe the first day, but it was just like a quick little note on it. So, which is actually not like increasing or decreasing. I think some of us are looking at it like it's increasing or decreasing. So this graph right here is the graph of f positive or negative? Positive. Right, because that graph is above the x-axis. So that graph is positive that we're looking at here. And then, but the graph is decreasing for that. So I was seeing several of you, like your positive and negative didn't look right for that first part. So double check that, keep looking, and then I want you to check with the person beside you and see if you're getting the same answers as them. Okay, I'm just going to call on some of you for the answers and see what we got. So let's see, Will, what did you get for, this would be easier to do if it was numbered. The rate of change of f is positive or negative. What did you get here? Negative, right? And that is because the graph of f is decreasing. Since the graph is decreasing, rate of change is negative. If I drew in little tangent lines here, they would all have negative slopes, right? And then, Layla, what'd you get for the second part? The rate of change of f is increasing or decreasing? is not, wait, oh yes, it is increasing. Gosh, those negatives get me every time. Yes, increasing is correct. Because this is also synonymous with concave up, right? Since F is concave up, the rate of change of F is increasing. But I almost told Layla this was wrong, because our little tangent lines, when we draw them in, are getting less steep, which makes me want to say that the rate of change is decreasing. But the rate of change is negative here, right? So like if this is a -2, then this would be a -1, and this might be a -1/2. And when we're looking at -2, -1, -1/2, those numbers are actually increasing. The negatives get me, even though I should be an expert at this sometimes. All right, so questions here? All right, so let's see what we got on the next one. Aiden, what'd you get for the graph of G is positive or negative? Negative is correct. That one's below the x-axis, so that graph is negative. Let's see, Destiny, what'd you get for the graph of G is increasing or decreasing? Increasing is correct. Wonderful. From left to right, it is that graph of G is going up, so that's beautiful. Savannah, how about the rate of change of G is positive or negative? Positive is correct. That directly correlates to the fact that G is increasing, right? So like you can answer this question based off of this question every time. And then Zane, what have you got for the rate of change of G is increasing or decreasing? Decreasing. Very good. How can we tell that the rate of change is decreasing? Yeah, less and less steep with positive slopes, right? So we're talking like here maybe is 3, here maybe is 2, here maybe is 1, right? Those slopes are decreasing. And the graph is concave down, which means our rate of change of G is going to be decreasing. Beautiful. All right, so let's see. Braden, what have you got for graph of H is positive or negative? Positive. It's above the x-axis. Wonderful. Savannah, how about the graph of H is increasing or decreasing? Decreasing. Evan, what about the rate of change of H is positive or negative? Correct. Negative. If the graph is decreasing, the rate of change of H has to be negative. And then Ava, what about the rate of change of H being increasing or decreasing? Decreasing. That graph is concave down just a little bit. Evan was like, I don't know, I feel like they should have made this curvier for this type of question, right? And I might agree with them, especially out here. It really starts to look like a line, but I think it's curved down a little bit there. I'll try to go fairly drastic on quiz or test questions so you can tell the difference there. All right, any questions here? All right, so that's rates of change in linear and quadratic functions. Linear rates of change are very simple because we just think of this as the slope of the line, okay? You have a constant rate of change. Okay, so what we're primarily going to be focusing on this little section is being able to look at a table and tell if the function is linear or non-linear, quadratic, or neither, right? So the table above gives selected values of the function. Explain why f is not a linear function. So typically, with a linear function, we have a specified slope, right? Maybe we go, slope is 2/3. We go up 2 to the right 3, up 2 to the right 3, up 2 to the right 3, right? So we will usually see in a table a pattern where we go like from 4 to 7, we're going up 3. And from 7 to 10, we're going up 3. And from 10 to 13, we're going up 3. That's looking pretty linear to me. But the answer for this is no, it's not linear. Why? X's are not increasing by the same amount, right? So over here, we go up by 1. So that means the slope on that little section would be 3 over 1, right? Just 3, right? But then on the next one, we go up by 2 with our x coordinate. So change in y over change in x, my slope is 3/2. And then here, the slope would be 3/4, right? So, one way I would explain this is to say, while the values of f of x increase at a constant rate, the x values do not. So y'all watch out for those x values. Those x values here are increasing at an increasing rate. They're not going to give us something that is linear there. We're going to consider the quadratic function g of x equals x squared. First we're just going to make a table. If we need to make a table for something, we're just plugging the numbers in, right? So g of x is x squared, so we're just squaring -3. We'll get 9 here. We'll get 1 here. We'll get 1 here. We'll get 9 here. We'll get 25 here. We're just squaring all those numbers. Very simple, the most simple quadratic equation we could possibly have, right? That's our table. So if we're looking for the average rate of change from -3 to -1, that is our slope from -3 to -1, right? So I could do a slope formula. If I have a table, what I like to do is just do this. This is your change in y. That went down 8. Down 8. And then my x values went up 2. So I'm going to have a slope of -8 over 2. So I'll get -4 is the average rate of change there. From 1 to 1, well, that changes 0, right? While the x values go up by 2. And so that's going to just that'll give me 0 over 2. So I'll get 0. Then I've got 8 right here. Notice all of my x's are increasing by 2. I've got 8 over 2. That's 4. And then, let's see, from 9 to 25 is 16. And so that's 16 over 2, which will give me 8. So this is not linear, clearly, because if you have a linear table, you should see the slope is the same every time. A linear graph has the same slope no matter which point you're using, right? So you should see same slope every time. This is not linear, but what do you notice about the rates of change right here? They're just increasing by 4, while this is not linear. This goes up by 4, up by 4, up by 4, right? So AP likes to use this language right here. What do you notice about the average rates of change of g of x over consecutive equal length input intervals? Consecutive equal length input intervals means the x's increase or decrease, they don't necessarily have to be increasing, at a constant rate. It doesn't have to be like the x's are going up by 1. They can go up by 2s, they can go up by 4s, they can go up by 7s. But as long as the x's are increasing at the same rate, then the average rates of change are going to be the average, I'm going to do AROC, average rate of change of G of X is linear. So the rate of change of the rate of change is linear for a quadratic. So your assignment is going to ask you to tell from a table if functions are linear, quadratic, or neither. So here is what you want to do. You want, gosh, I thought we had till, never mind. You don't have to do the homework. We didn't get far enough. If we had 5 more minutes, we could have made it, but I forgot about the stupid different schedule. I live my life being behind. But no homework tonight, so that's good for you guys.